This video is an instruction on finding the domain and range of a function when all you have is its equation and you can't look at the graph. This is a topic that many students get confused by, and it doesn't have to be that difficult if you've got a little bit of patience and are willing to guess and check around with some numbers and play around with some number sense. There's a few things to think about when you're talking about the domain and range of a function. I'm going to start out by focusing on the domain because that tends to be the more commonly needed answer to problems when you're graphing and when you're doing a whole bunch of calculus stuff. And we'll talk about the range in a little bit. You start out by thinking, whenever you're given a function, that the domain of that function, the domain being the x values, right, all the x values that you can plug into the function, start by assuming that the domain of a function is all real numbers from negative infinity to infinity, that you can plug in anything you want. And then you just want to kind of scale back on that and see if, well, are there any numbers that you plug into the function that, for example, give you non-real numbers? For example, square rooting a negative. You can't take the square root of a negative number and get a real numbered expression or a real numbered value. We also can't divide by 0 because division by 0 is undefined. So those are the two things that we need to be careful for. We need to watch out for roots. We need to watch out for taking square roots or fourth roots or any even number root that will give us an imaginary number. And you also need to be careful for division because dividing by 0 is not defined in the real number system. So for example, if I take a look at a function like, let's say f of x equals x squared plus x plus 5, we go through and just think, okay, well, are there any numbers we can't square? No, any number can be multiplied by itself. To that, can we add that number? Of course, you can add that number to the square of itself anytime, and no matter what number we work with, that ends up happening. You can also add 5 to that. So in general, most polynomial functions, quadratics, linear functions, most polynomial functions, or rather all polynomial functions, the domain will be all real numbers. If we branch out a little bit, for example, like f of x equals the square root of x. And now we think about, okay, on a number line, are there any numbers, if we assume we can plug in anything from negative infinity to infinity, are there any numbers that we can or cannot plug in? So let's say if we start with 100, yeah, we can take the square root of 100. That's going to be 10. That's okay. Maybe how about if we plug in 5, right? Well, the square root of 5, that's a real number. It's going to be a decimal. It's irrational, but that's fine. I think 0, we're going to take the square root of 0. That's going to be 0. That's okay. But then we think go a little bit below 0, maybe 1, or sorry, negative 1. If I try to take the square root of negative 1, that's the imaginary number I, which is undefined. So we really have a domain in this case that includes 0 and all numbers positive, but nothing below 0. So the domain of this function would be from 0 to infinity. It's the same concept that we need to be careful about when we're dealing with denominators. When we are dealing with denominators, we need to be careful about dividing by 0. So for example, f of x equals, let's do a simple rational function, 1 over x. Same process. Okay, well, can I plug in 100? Yeah, that'd be 100th. Can I plug in 1? Let it be 1 over 1. We really want to focus in on this denominator. What number is the only number I'd plug in there that would make us divide by 0? And that would obviously be 0, 1 over 0. And this expression here is undefined. We can plug in some negative values, or 1 over negative 1, that's okay, that's just negative 1, and so forth. So the places where we have an issue here tend to be everything except for 0 is part of the domain of this function. We're going to look at a little bit more complicated example. We're going to take the function f of x equals the square root of x minus 6. And now we need to think which rule we work. So we're gonna start out thinking any number works. But as soon as we see that we've got this square root symbol, we know we have to be careful because the square root of whatever is inside, this stuff inside needs to be bigger than or equal to 0. It must be positive. We say, okay, well, what is on the inside? X minus 6. So we need x minus 6 to be bigger than or equal to 0, which means x needs to be bigger than or equal to 6. So on a number line, we can plug in 6 and any number bigger than 6. So our domain is going to be from 6 to infinity. So we'll just shrink this up a little bit, and we'll summarize, and we'll just say here that for this function, the domain is 6 to infinity. The function f of x equals 5 over 2x plus 1. In this one we notice that there's no square roots, but we do have a denominator that we need to be careful about. And the rule is that any function, this structurally looks like 5 divided by some quantity. We need this quantity, whatever it is, to not be equal to 0. So we're going to take that quantity, which is 2x plus 1, and say, okay, well, we want that not to be equal to 0. We'll just solve that equation. That's the only value, this x that we're going to find out that gets this equal to 0 will be the only value that makes that denominator equal to 0. So we'll solve. We'll say, okay, well, this is 2x can't be equal to negative 1, which means x can't be equal to negative 1/2. So if we're thinking of this on a number line, what this really looks like is this. We've got our number line, right? And we think about it. This is all possible x values. We know that negative 1/2 is out. We can't plug in negative 1/2. Let's see what happens if we do. 5 over 2 times negative 1/2 plus 1. Well, that's 5 over negative 1 plus 1, which is 5 over 0, and this is undefined. So that doesn't work for us. So we're going to put a big open circle on negative 1/2. But as we get above the negative 1/2, we plug in 0, plug in 1. Those will all work. So we're going to say our domain is every value except negative 1/2. And the way we would write that using interval notation would be like this. We'll say that the domain is from negative infinity to negative 1/2 with a soft bracket, or a parentheses rather, around the negative 1/2, and then from negative 1/2 to positive infinity. We're going to put, remember, soft bracket, parentheses, because negative 1/2 is not part of the domain. A lot of times you could say that the domain is all real numbers such that x is not equal to negative 1/2. And that's allowed, but the interval notation is sometimes more concise and a little bit more of a positive example, because we're asking what values of x are in the domain as opposed to which values are not in the domain. So it's sometimes it's more of a positive answer to frame it like I did down here in interval notation.